Welcome to Statistics, where we bring complexity to clarity. I'm excited to have you join me for our 12th unit, Sampling Methods. What is sampling? Sampling is a part of our everyday life. For example, a housewife takes 1 or 2 grains of rice and decides whether rice is cooked or not. Or a pathologist takes a few drops of blood and tests for any change in blood of the whole body than normal, etc. are the examples of sampling. What are the objectives of sampling? The objectives of sampling are to study the population or to provide correct method or methods for taking sample or sampling. Let's see the terminologies associated with sampling. Starting with population. A population is the aggregate of individuals or units or objects having at least one common characteristic. It is also called universe. Sample. A sample is a part or fraction of large aggregate, that is population, about which some information is required. A sample is a true representative of the population. Sampling. It is the method or process of selection of sample from the population. Sampling unit. It is the individual element or a group of elements on which observations are to be made. Sampling frame. For adopting any sampling procedure, it is essential to have a list identifying each sampling unit by a number. Such a list or map is called sampling frame. For example, a list of voters, a list of villages in a district, a list of farmers, etc. Parameter. Any measurable characteristic of population which is to be worked out by utilizing each and every observation of population is called parameter. It helps to characterize the population. Mean mu and standard deviation sigma are the example of parameter. It is generally unknown and constant. Statistic or estimate. Any number estimated from sample is called statistic or estimate. Example, x bar and s are the statistic for mean and standard deviation respectively. Random sample. Every individual of the population has an equal and independent chance of being selected in sample, then it is considered as random sample. Sampling size. The number of sampling units included in the sample constitutes of sampling size. Sampling fraction. It is the ratio of sample size to the population size, that is small n by capital N, where small n is the sample size and capital N is the population size. Let's see types of population. There are 4 types of populations, namely finite, infinite, real, and hypothetical population. Finite population. Counting the individuals in the population is possible and hence it is finite population. Example, rose plants in garden, number of animals in herd, fruits on tree, etc. Infinite population. Counting the individuals in the population is impossible and hence it is infinite population. Example, stars in the sky, number of microbes on earth, etc. Real population. This is the population in which the members do exist in reality. Example, a heap of food grains, herd of cows, etc. Hypothetical population. The member of population does not exist in reality. Example, possible throws of a die, possible results of an experiment, etc. The information on population can be collected in 2 ways, namely through complete enumeration or by sampling. Complete enumeration, also known as census survey. In complete enumeration, every element of the population is included in the investigation. For example, if we study the average annual income of the families of a particular village or area, and if there are 1,000 families in that area, we must study the income of all 1,000 families. In this method, no family is left out as each family is a unit. For example, the population census of our country is taken at 10 yearly intervals. Let's see the merits of complete enumeration. The data are collected from each and every item of the population. The results are more accurate and reliable because every item of the population is required. Intensive study is possible. The data collected may be used for various surveys, analysis, etc. Let's see the limitations of complete enumeration. It requires a large number of enumerators and it is costly method. It requires more money, labor, time, energy, etc. It is not possible in some circumstances where universe is infinite. Now let's see sampling. The theory of sampling has been developed recently, but this is not new. In our everyday life, we have been using sampling theory as we have discussed in introduction. In all these cases, we believe that the samples give a correct idea about the population. That is, samples are the true representative of the population. Most of our decisions are based on the examination of a few items, that is, sample studies. In what situations sampling is inevitable? Sampling is inevitable when the population is infinite, when the item or unit is destroyed under investigation, when the results are required in short time, when the resources for survey are limited, particularly in respect of money and trained persons, or when the area of survey is wide. Let's see the advantages of sampling. Sampling saves time and labor. It results in reduction of cost in terms of money and man-hour. Sampling ends up with greater accuracy of results. It has greater scope. It has greater adaptability. If the population is too large or hypothetical or destroyable, sampling is the only method to be used. Let's see the limitations of sampling. Sampling is to be done by qualified and experienced persons. Otherwise, the information will be unbelievable. Sample method may give the extreme values sometimes instead of mixed values. There is the possibility of sampling errors, whereas in complete enumeration, sampling error is absent. The technique of selecting a sample is of fundamental importance in sampling theory and it depends upon the nature of investigation. The sampling procedures which are commonly used may be classified as non-probability sampling, probability sampling, and mixed sampling. Non-probability sampling consists of convenience sampling, judgmental sampling, quota sampling, and snowball sampling. Probability sampling consists of simple random sampling, stratified, multistage, cluster, and systematic sampling. We will be discussing them in detail. Let's see non-probability sampling. It is the one where discretion is used to select representative units from the population or to infer that a sample is representative of the population. This method is called judgment or purposive sampling. This method is mainly used for opinion surveys. A common type of judgment sample used in surveys is quota sample. This method is not used in general because of prejudice and bias of the enumerator. For example, in the market research survey of the performance of their new car, the sample was all new car purchasers. Let's discuss probability sampling. A probability sample is one where the selection of units from the population is made according to known probabilities. The examples of probability sampling are simple random sampling, stratified random sampling, multi-stage sampling, cluster sampling, and systematic sampling. Let's see simple random sampling. In a simple random sampling, the sample is selected in such a way that every member of the population has an equal and independent chance of being selected in the sample. It means selection of a sample from all possible samples that could be chosen is equally likely. This method is very useful when population is homogeneous. For finite population of capital N units, there are NCN different samples of size small n. Every one of being selected if no restrictions have been placed on the population. Let's see the example. Consider that there are 6 units, namely A, B, C, D, E and F, that is capital N is equal to 6 in the finite population, and one would like to draw a random sample of size 2, that is small n is equal to 2. Then possible samples are as shown. Any one of these samples can occur in selection with equal probability 1 by 15. As we saw, that total number of possibilities is NCN, which is written as NCN is equal to 6C2, which is equal to 6 factorial upon 2 factorial into 6 minus 2 factorial, that is 15. Random selection of units is done by using any one of the following methods. For example, using tickets, tags or slips, etc., or through random number tables. In case of using tickets or tags or slips, if we have a population with 100 units and we want to have a sample of 10 units, then we have to make 100 tickets and pick 10 tickets randomly. As we have picked the tickets randomly, it constitutes of random sampling. Or in case of random number tables, we can refer statistical tables book and select a random number table to get the sample from the population. Examples of simple random sampling. Choose the names of 25 employees out of a hat from a company of 250 employees. In this case, the population is all 250 employees and the sample is random because each employee has an equal chance of being chosen from the hat. Stratified random sampling. In this scheme, the population is subdivided into several groups called stratum and then samples are drawn independently at random from each stratum. Of all these methods of sampling, the procedure commonly used in surveys is stratified sampling. This technique is mainly used to reduce the population heterogeneity and to increase the efficiency of the estimates. Stratification means division into groups. In this method, the population is divided into a number of subgroups or strata. The strata should be so formed that each stratum is homogeneous as far as possible. Then from each stratum, a simple random sample may be selected and these are combined together to form the required sample from the population. The examples of stratified random sampling are adoption level of improved agrotechnology by the cultivators, a survey for nutritional status of school-going students, or socio-economic survey for rural and urban people of Anand district. Multi-stage sampling. In this method, the selection is done in stages called subsampling. For example, in estimating the yield of wheat in a district, talukas may be considered as primary sampling unit, that is first stage, villages within taluka as secondary sampling units, that is second stage, and the cultivator within village within taluka as tertiary sampling units, that is third stage, and so on. Cluster sampling. In many situations, the sampling frame for elementary units of the population is not available. Moreover, it is not easy to prepare it. But the information is available for groups of elements, so-called clusters. For instance, the list of houses may be available, but not the persons residing in them. Or the list of individual farms may not be available, but the list of villages is generally available. Hence, in these situations, houses or villages are known as clusters, and selection has to be made of houses or villages in the sample. Such a sampling procedure is known as cluster sampling. Systematic sampling. Systematic sampling is slight varying compared to simple random sampling, in which only the first sample unit is selected at random and the remaining units are automatically selected in a definite sequence at equal spacing from one another. This technique of drawing samples is usually recommended if the complete and up-to-date list of the sampling units is available and the units are arranged in some systematic order such as alphabetical, chronological, or geographical order, etc. This requires the sampling units in the population to be ordered in such a way that each item in the population is uniquely identified by its order. For example, the name of persons in telephone directory, the list of voters, etc. Mixed sampling. Here samples are selected partly according to some probability and partly according to a fixed sampling rule. They are termed as mixed samples, and the technique of selecting such samples is known as mixed sampling. Sampling and non-sampling errors. The inaccuracies or errors in any statistical investigation, that is the collection, processing, analysis, and interpretation of the data, may be broadly classified as follows: sampling errors and non-sampling errors. Sampling errors. In a sample survey, since only a small portion of population is studied and hence its results are bound to differ from the census results and thus has a certain amount of error. This error would always be there, no matter that the sample is drawn at random and that it is highly representative. This error is attributed to fluctuations of sampling and is called sampling error. Sampling error is due to the fact that only a subset of the population, that is sample, has been used to estimate the population parameters and draw inferences about the population. Thus, sampling error is present only in a sample survey, while it is completely absent in census surveys. Sampling error may be due to following reasons: faulty selection of the sample, substitution, faulty demarcation of sampling units, error due to bias in estimation method, or variability of the population. Non-sampling errors. Non-sampling errors are not attributed to chance and are a consequence of certain factors which are within human control. In other words, they are due to certain causes which can be traced and may arise at any stage of the inquiry, namely planning and execution of the survey and collection, processing and analysis of the data. This error is present in sample and census survey both. Let's see the factors responsible for non-sampling errors. They are faulty planning, vague and imperfect questionnaire, defective methods of interviewing and asking questions, vagueness about the type of data to be collected, personal bias of the investigator, lack of trained and qualified investigators and lack of supervisory staff, failure of respondents' memory to recall the happenings in the past, non-response and inadequate or incomplete response, improper coverage, compiling errors, or publication errors. Thank you for joining me on this journey through our 12th unit sampling methods. If you found this unit helpful, don't forget to like, share and subscribe to Statistics for more insights and clarity on statistics. Your support helps us continue creating content that makes complex topics simple and accessible. Follow us on Instagram and LinkedIn.